Welcome to qnawire.
Hello students, in the first question by using the results of the study, we have to run independent t-test and see if there is a statistically significant difference in the mean score at the level of significance 0.05. So for that we have given the data of the two groups, that is group 1 and group 2. So by using that we want to test the hypothesis H0 mu1 is equal to mu2 versus the alternative hypothesis H1 mu1 is not equal to mu2. So that means the given test is a two-tailed test. So first we will calculate the pooled variance and which is given by the formula S square is equal to n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. So substituting all the values in this formula, that is 15 into 7.79 bracket square plus 15 into 7.74 bracket square and divide by 15 plus 15 minus 2. So the value of s square is equal to 64.6027, and then we will get the required value of SDM, which is equal to the square root of 64.6027, and that is equal to 8.0375. This is the required standard deviation. Then the test statistic. It is calculated by using the formula T is equal to m1 minus m2 divided by s square into bracket 1 upon n1 plus 1 upon n2, and this whole term is inside the square root sign. So now we have given the value of m1 and m2, which is 16.6 minus 27.07 divided by s square is 64.6027 into bracket 1 upon 15 plus 1 upon 15, and this is inside the square root sign. So we will get the required value of the test statistic is approximately equal to minus 3.567, and that is equal to minus 3.57. Then the degrees of freedom for the given t-test is n1 plus n2 minus 2, which is equal to 15 plus 15 minus 2, and that is equal to 28. Then by using this test statistic value we can compute the p-value. So p-value is equal to the probability of the test statistic, that is a t is greater than minus 3.567, and by using the t table this probability is 0.0013. Then we know that when the p-value is less than the significance level, then we reject the null hypothesis. So here, since the p-value, which is equal to 0.0013, it is less than alpha is equal to 0.05, so therefore we can reject H0. Therefore we can conclude that there is a sufficient evidence to conclude that there is a significant difference in the mean scores. Then in the second question, there is also we have given the data for the two groups, and we want to test the hypothesis to check whether there is a statistically significant difference in the mean score. So that means we want to test H0 mu1 is equal to mu2 versus the alternative hypothesis H1 mu1 is not equal to mu2. So first we will compute the value of s square, which is n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2, and substituting all the values here we will get this is equal to 10 into 8.68 bracket square plus 10 into 8.54 bracket square divided by 10 plus 10 minus 2. Therefore the value of s square is 82.374, and we will get the required value of the standard deviation, that is SDM, is the square root of 82.375, which is 9.076. Then the formula for the test statistic is m1 minus m2 divided by s square into bracket 1 upon n1 plus 1 upon n2, and this is inside the square root, which is equal to 44.5 minus 28.10 divided by 82.374 into bracket 1 upon 10 plus 1 upon 10, which is inside the square root. So the value of the test statistic is approximately equal to 4.949. Then the degrees of freedoms are n1 plus n2 minus 2, that is equal to 18. Therefore, p-value by using the test statistic is probability of t is greater than 4.949, and by using the t table, this probability is 0.000104, and here since this p-value is less than alpha is equal to 0.05, so therefore the decision is we are rejecting the null hypothesis, that is H0. That is, we can conclude that there is a statistically significant difference in the mean scores. So I hope you find this video useful. Thank you.